Let's move on towards our next lecture of matrices. So this question number 3 is the thing which we are going to solve right now. So the question number 3 says as follows: a matrix B, a matrix capital B of order n cross n. What does it mean by order n cross n? N cross n order simply implies that there are n rows and there are n columns. Okay, so there is a matrix B whose order is n cross n and it is of the form lambda A as shown over here. Okay, where lambda is a scalar and A has unit elements everywhere except in the diagonal. A has what? A has unit elements everywhere except at the diagonal. At the diagonal, the element is mu, but in other places except diagonal, the elements are 1. Okay. So we have to determine lambda and mu so that B may be orthogonal. Okay, this value of lambda we need to determine and this value of mu we need to determine so that B may be orthogonal. Okay. Now, B is equal to lambda A as already given to us in the question. So we are starting with this statement. Now B transpose B will be equal to what? It will be equal to lambda A whole transpose into lambda A. Just substituting instead of B, we are substituting lambda A over here, and instead of B, we are again substituting lambda A over here. So lambda A complete transpose multiplied by lambda A is the thing which we got from here. Okay. Now clearly B transpose B will be equal to what? B transpose B will be equal to lambda. Lambda will come out of the transpose because it is a scalar. It is a scalar, so it will come out of the transpose sign. So what will happen? Lambda multiplied by A transpose multiplied by lambda multiplied by A will occur. Okay. Then what will happen? Lambda and lambda will come together. They will give lambda square, and A transpose multiplied by A will occur. Okay. So that is the thing which we have got in this particular slide, that lambda square A transpose A, B transpose B is equal to lambda square A transpose A is the thing which we got. Now already it is given to us that matrix A is equal to something like this. Okay, n cross n. So matrix A is n cross n matrix. Why it is n cross n matrix? Because B is equal to lambda A and lambda is a scalar. It is already given to us that this is n cross n matrix. This B is n cross n matrix. Lambda is what? Lambda is a scalar. So as a result, matrix A will also be n cross n matrix. It will also be n cross n matrix. That is, it will also have n rows and n columns, right? So we have written here n cross n matrix A. This matrix A has been written over here, and it is n cross n matrix. Okay, although it is not written here, but it is n cross n matrix. Also it is given that all the elements at the diagonals are equal and equal to mu. So all the elements at the diagonals are equal up to the last row. So all the elements at the diagonal are equal and equal to mu, and all the non-diagonal elements are what? Equal to 1. All the non-diagonal elements are equal to 1. Okay. Now let us take its transpose. So clearly its transpose will be equal to the same matrix. Okay, when we take its transpose, it will be equal to A itself. Okay. Why it will be equal to A itself? It will be equal to A itself because it is a symmetric matrix clearly. Okay, because all the corresponding elements above and below the principal diagonal, as they are 1. Okay, all the corresponding elements above and below the principal diagonal are equal to 1. So it is a symmetric matrix. So transpose will be equal to the same matrix. So A transpose can be written like this and A can be written like this. So both of them are same matrix. This matrix and this matrix are same. Okay. Now, if you want to take the product of A transpose and A, if you want to take the product of A transpose and A, what will happen? You will multiply the elements term by term. You will multiply the elements term by term, right? So this first row will get multiplied with this first column, and the result you will write over here. Okay. Then this first row will get multiplied by this second column, and the result you will write over here. Then the third row, then the first row will get multiplied with the third column. The result you will write over here. Okay, so on and so forth. So on and so forth. You will continue to move till the last row. Then this first row will be multiplied by nth column. Okay, and the result will be written over here. The first row will get multiplied with this nth column, and the result will be written over here. Then what will happen? This second row will start and it will get multiplied with first column, and this element will occur. Okay, this element will turn out. Okay, then this second row will get multiplied with this second column, and this element will come. Okay, So in this manner the elements can be written, all the elements, and this matrix by the way will also be n cross n matrix. This matrix by the way will also be n cross n matrix. Okay. Now some students might find it difficult to find out the individual elements, but what I am telling you to do is that this first row just multiply it with first column and have a look at what will be the result. So mu multiplied by mu will be mu square. Okay. Then 1 multiplied by 1, then mu square plus 1 will happen. Then 1 multiplied by 1 over here. Okay. This 1 multiplied by 1 over here, which is not visible. Okay. So in this manner mu square will, in the place of q, mu square will come, and these are what? These are n minus 1. How many ones are there? How many is the number of 1 over here? Over here the number of 1 is n minus 1. Okay. And over here the number of 1 is again n minus 1. Okay. N minus 1 ones are there. Okay. So if you multiply the corresponding elements, this particular element q will come out to be equal to mu square plus n minus 1. Okay. And such element mu square plus n minus 1 will repeat in the diagonals. Okay. This element mu square plus n minus 1, this value will repeat at the diagonals. Okay. And the off diagonal elements will come out to be 2 mu plus n minus 2. How are the off diagonal elements coming out to be 2 mu plus n minus 2? So have a look how we are finding the off diagonal elements. So while trying to find out the off diagonal elements, this row will get multiplied with this particular column and the result will be written over here. So if you try to multiply, what will happen? This mu will get multiplied with this one. So mu has occurred. Then this one gets multiplied with this mu. So mu plus mu is equal to 2 mu. Okay. And then after that there are n minus 2 ones. There are n minus 2 ones present over here. And over here also n minus 2 ones are present. So 1 into 1 into 1 into 1, 1 into 1, 1 into 1, 1 into 1, how many times? N minus 2 times. Okay. So this p, that is the off diagonal element, will come out to be equal to 2 mu plus n minus 2. Okay. If you are getting confused, then just do it in the rough work. Just take a rough piece of paper and try to multiply this element, this matrix. Try to multiply this matrix and this matrix. Okay. On a rough sheet of paper, you will realize that this is the matrix which we will get. This is the matrix which we will get. Okay. So the diagonal elements will be q, 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 q. Okay. And the off diagonal elements will be p, 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 p. Those will be the off diagonal elements, and diagonal elements will be q. And q is equal to mu square plus n minus 1. Okay. So the value of q is mu square plus n minus 1, and the value of p is 2 mu plus n minus 2. Okay. These are the two values. So at the place of q, this is the expression, and at the place of p, this is the expression. Okay. Now B is an orthogonal matrix, already given to us in the question. Okay. Nothing new in that. So as B is an orthogonal matrix, so B transpose is equal to B transpose B is equal to identity matrix. Okay. So this particular entire expression B transpose B is equal to B transpose, and that is equal to IN. IN denotes a identity matrix. IN denotes an identity matrix of n cross n order. Identity matrix of n cross n order. So this is equal to what? 1, 0, 0. Okay. Up to 0. Then 0. Up to 0. Okay. Then up to 1. Okay. This is the n cross n. This is the n cross n unit matrix. Okay. Identity matrix. n cross n identity matrix. So just equate. Okay. Just equate this particular expression to identity matrix. Now while equating this particular expression to identity matrix, what will happen? The thing which will happen is that these elements will be equal to, these elements multiplied by lambda square will be equal to 1. This element multiplied by lambda square will be equal to 1. Up to this element multiplied by lambda square, that will be equal to 1. Okay. And what about the off diagonal elements? This element multiplied by lambda square will be equal to 0. This element multiplied by lambda square again will be equal to 0. Okay. Because it is an identity matrix of order n. Okay. Order n, that is n cross n order, identity matrix of order n. Okay, so these things, the q lambda square into q will turn out to be 1. Clearly from here, lambda square q will turn out to be equal to 1 and lambda square p will turn out to be equal to 0. Okay. So this entire expression should be equal to 1 and this entire expression, okay, multiplied by lambda square obviously. Lambda square multiplied by this entire expression should be equal to 1 and lambda square multiplied by this entire expression, lambda square multiplied by this entire expression, that should be equal to 0. Okay. So have a look at it in the next page. So lambda square q is equal to 1, lambda square p is equal to 0. Okay. So lambda square at the place of q, what is the expression? Mu square plus n minus 1, that is equal to 1, and at the place of p the expression is 2 mu plus n minus 2. So lambda square multiplied by 2 mu plus n minus 2 and this expression is equal to 0. Okay, this is the expression which is equal to 0. Now from equation 1 and from equation 2 what can you get? From equation 2 one can get 2 mu plus n minus 2 is equal to 0. So 2 mu plus n minus 2 is equal to 0. Why? Because lambda cannot be 0. Okay, lambda cannot, see the product of lambda square and this expression is coming out to be equal to 0, but lambda cannot be 0. Why it cannot be 0? Because if lambda is equal to 0 the matrix will vanish. Okay, so lambda is not equal to 0, so obviously this expression must be equal to 0. For the product to be 0, this expression must be equal to 0 because this expression cannot be 0, otherwise the matrix will vanish if this is 0. So this cannot be 0, so this must be 0. So from equation 2, 2 mu plus n minus 2 will be equal to 0. 2 mu plus n minus 2 is equal to 0. So from here 2 mu is equal to 2 minus n. 2 mu is equal to 2 minus n. So mu will be equal to what? Divide both side by 2. Both side by 2. Okay. So 2 mu will give mu equal to 1 minus n by 2. 1 minus n by 2. Now put this value of mu obtained from equation 2 in equation 1. Put this value in equation 1, this particular expression. So after putting, what do you get? Lambda square and lambda square written as it is. At the place of mu I am writing 2 minus n by 2. Okay, so whole square and plus n minus 1, that is equal to 1. Just expand this expression. What will happen if you expand? 4 plus n square minus 4n. So 4 plus n square minus 4n minus 4 plus 4n minus 4. So plus 4n minus 4. Okay, and this 4 from the denominator will go over here. So this is the expression which you get. This is a very simple algebra. I am not going to explain this simple step. Okay. So after substituting this value of mu from obtained from equation 2 and this value of mu, after you substitute it in equation 1, what do you get? You get something like this, and the final expression which you get is lambda square n square is equal to 4. Lambda square is equal to 4 by n square. So lambda from here comes out to be equal to plus minus 2 by n. You take square root on both the side. From here this expression you will take square root on both the side, and after you take square root on both the side, 2 will come 4 will become 2 after taking square root, n square will become n after taking square root. Okay, and plus minus sign will appear over here. Plus minus sign will appear over here. Okay, so this is the value of lambda which you get. Okay.